Variables and conditionals, movement, and the magic of -1. So variables are a way that we store information. So in programming, we often will need to refer to something more than one time in our program. And when we do that, we need to have an ability to make a reference to that. So we have to store that information. And that information could be a number, it could be a word, it could be an object, it can be a property, it can be a group of objects or words, numbers, letters. So we need to be able to store that information somehow so that we can access it in the future. So if we want or need to access it, use a variable. A general concept to follow in programming is if you are going to refer to something or need to access it more than one time, store that reference as a variable so that it allows you greater control over your program. There are different kinds of variables that we will use. So the common ones will be int, float, char, string, and boolean. You will notice that string has a capital S. The other variable types are all lower case. So an integer is a whole number. So it can be a positive value, it can be a negative value, it can even be 0. But it is a whole number. It does not have a decimal point. It doesn't have anything after it. And that is in direct contrast to a float, because a float may or may not have a decimal point. So 0 is a float. 0.0 is a float. 12.34, floats can be negative, they can be positive. But what a float means is we have a greater amount of precision because we are able to then have a decimal point. And depending on our use for that number or precision required will determine how many places after the decimal point we are going to have. Now, characters are individual letters. And that individual letter, it could be more appropriate name would be than individual symbol, because anything that we store as a character, whether it's a comma, a period, alphabetical letter such as A, B, C, D, numbers we can store as characters instead of storing them as a number value, but characters are individuals. Now a string is different because it's a combination of individual symbols or characters that we use. So it's one or more. Now string is denoted with a capital, and that's part of the programming convention because a string is defined as being a group of characters. So because of that, it's not a primary data type, but it's a combined data type, and because of that, it's technically then using the string class. We'll talk more about classes in an upcoming session, and by convention when programming we use capital letters when we are referencing a class object. Now a boolean is a variable that will store one of two values, true or false. And this will be important when we look at conditionals, because a conditional function is where we say if something is true, then do, and we list what we want it to do, else do something else. So a conditional is asking a question, and we'll be looking at how we use those and how we write those. But conditionals and booleans are very much tied together because the conditional, when we ask the if question, we're asking if something is true. On this grid, if I move this red ball around, we notice how the numbers change. It's important to pay attention to the number as I'm in the top left corner, and it works its way up to, gives me a minimum of 1, 1, and I work my way down to the bottom right corner, and we're able to get to a bigger number of 1198 and 797. So what this is I can go from 0, 0 to 1200 by 800. That's what size this grid has been set up at. So we know that we're starting at 0, 0. We're now going down to 1200, 800. And as I move around, that number is changing. Now, as I move horizontally, I'm referring to moving along the x-axis of my sketch. When I move vertically, I'm moving on the y-axis. So we notice that the number gets bigger as we travel down and right. So that's going to be important because we're going to now use this number as a way of storing it so that we can then draw a more complicated object than a simple circle and have this whole object move. We could move it based on where the mouse is, but we're going to move it based on a changing x and a changing y value so that we can create movement inside our sketch. But like everything else, when we begin the process, what we want to do is we want to start out with something simple like a red ball. Once we can move that, then we will add additional elements to the sketch showing how we can build more and more complexity. But anytime you are trying a new concept in programming, it's very important to start with something very basic and simple to develop a proof of concept. Starting in a new sketch, what we're going to do is draw a simple circle on screen, and then we are going to make it move or animate on the screen. So to accomplish that, we have to learn a new concept as well. And what that is a function. So we need to set up our sketch, and we have a function that does it. The setup function is where we are able to designate all of the preliminary elements for the sketch, where we get everything ready to go for the main program to run. A common thing that we would do would be to put in the size. Then I may type in background color, and with that I'm just going to leave it at just middle gray for now. Now when we type these functions, we'll notice that there's a certain syntax to that. So I have a word here, void, and functions can return a value, or functions can just perform an operation. And if they perform an operation, they don't return anything to us. So we could have a math function where we pass two numbers into it and say add those new numbers together and then return to me the sum of those two numbers. So that would have a return value of a float or an int, depending on if we're passing in whole numbers, expecting whole numbers back, or if we're using floating point numbers. But functions that return nothing, they just do something, will have a return type of void, meaning nothing is expected back. And there are two functions that are commonly used in processing: setup and draw. Now, when we wrote our programs previously, we didn't use draw, so we executed all of our instructions one time. But if we're trying to update what is appearing on screen, then we are going to need to be able to update that information. So when we have a function, we follow the function name. So the function name here is setup, the function name here is draw. We follow it with parentheses, and inside those parentheses we can sometimes pass values into it for the function to do something with that value. In this case we're not going to. And then we use a curly brace, hit return twice, put in your closing curly brace, and then that wraps out the function. So if you get in the habit of every time you do an open curly brace, hit return twice, and do a closing curly brace, your life is going to be much happier, because then you won't have missing closing curlies and then your program fails to run. So now inside of draw, what we can do is I can just simply say fill 255 0 0. So that's going to fill it with red, and now I want to fill it with a transparent red. So I'm going to use 100 just because I can. Now I'm going to say circle, and we'll draw the circle at 100, 100, and we'll make it 100 pixels across. Now if we run this, you see it draws a red circle and puts it there on screen. So it's not moving, it's not animating, it's just parked. So we've introduced a new concept here, and that is functions. We will get in the habit of using functions quite extensively as the course progresses. You will be writing your own functions. Sometimes we use functions that are part of the program, such as setup and draw, and other times we will have functions that we get to write and we create. Now, naming conventions on functions, they generally start with a lowercase. We sometimes will make a function name be a couple words together to give us some explanation of what that function is doing, so that our code is more human readable. So we have a circle. It's not that interesting because it's part. We want it to move. It's kind of the whole point of what we're doing here. So to make that move, what we need to do is we need to store its position. So we're going to just use whole numbers. We'll use int for it as our variable type, and I will say int x. And I will also say int y. So now I have an x and a y value, remembering we can move across the screen along the x-axis or the y-axis. Now I want to preset these, or give them initial starting values. So I say x is equal to 100, and I will say y is equal to 100. Now, instead of drawing my circle at 100, I'm just going to draw it at x and y. So, and I also auto-formatted using Command T or Control T. Auto-format puts the spacing in and makes it all nice and pretty looking. So now if I run this, it's going to look exactly the same. But the real beauty here is, now that I have a reference to that, I can change x and y. So if I want to update x, I can say, x, why don't we say x is now going to be equal to x plus 1. So we'll say x is equal to what the old value of x was, and we add 1 to it. So it starts out at 100. We add 1 to it, it'll become 101, then 102, and 103. Now, when we look at that circle on screen, what we will see is the circle is slowly moving its way across the screen, 1 pixel at a time. Now it's also leaving a trail behind as it goes. So when we do that, what we could do is we can clear the screen. So every time we draw the objects on screen, then draw will execute. Now draw executes approximately 60 times per second. So it updates, so the draw function runs 60 times per second. So if we just call the background, and when we do that, it floods or fills the background with that color. Now when it runs, we can see the circle is moving across the screen. We also see now the transparency is visible because it's not stacking red on top of red on top of red on top of red on top of red. So it's pretty cool. Now if we moved it faster, and just so we can see that, I'm going to turn off the background fill there. We'll see how it flies across the screen moving 10 pixels. See how it starts transparent and then becomes more opaque as the red is stacked on top of the red, and because it's at 100, so after approximately 2.5 times it should be full opaque red, because knowing that the transparent value here I put in 100, but 255 would be considered fully opaque. That's why 2.5 times. So now the circle is moving. If we redraw the background, we can see it's moving, but it does fly all the way off the screen. So it's getting there. Now let's just try, just because we can, y is equal to y plus 10. Let's see how this turns out. When we do that, it now moves diagonally down, and then it disappears and flies off the screen. So that's not really, and that's good, it's moving, but we want it to stay on screen. So what we need to do is we need to then start asking questions. We need to say, hey, you know, if the X is bigger than the full width of the screen, let's pop it back and make it go in the opposite direction. So we'll create a bounce when it hits, or we can look at hitting a screen wrap. So when it gets off the screen, we can make it wrap back to the other side asteroid style. But first we're going to start with the bounce and see how that plays out. So the first thing I'm going to do is we're going to limit it first to the X movement, moving on the X-axis. So I'm just going to comment out that. Again, the quick command to comment is command /. So right next to the right shift key, underneath the question mark, you see the /. So command or control / will comment and uncomment. You don't have to highlight, just put your cursor anywhere in a line and it will add in that comment for you. So what we need to do is kind of talk through this. We need to put what we're trying to do in plain language. So we want to check and find out. So our program makes X get bigger, but if X gets too big, so I'm going to write it in comment so it doesn't give me an error. So if X is equal to or bigger than the right edge, start moving to left. So what we need to do is we need to flip it. Now, there's a couple of different ways that we could work with this and try and write it, but we're going to start out with the simplest. So we say if our condition that we're checking for, it goes inside those parentheses, and then I do a curly brace, and remember every time we do an open curly brace, hit return twice and then put in your closing curly brace. So the condition we're looking for here is if X is equal to or bigger than the right edge. So the way that looks is X is greater than or equal to, and now our right edge. Well, we know that the left is 0, the right is 800. So I can type in 800. We also have another program variable that we have access to without having to create it, and that is width. Width will be the width of our sketch as specified in our size statement. So by making that size statement, we now can just specify width. So we don't have to hard code in a number. So I prefer to do it that way. So if x is greater than or equal to the width, then what we want is move to left, because right here we are moving to right. So we're trying to flip it, and this is where it gets kind of fun. Doing that flip, we essentially are going to say x is equal to x minus 10. Now, if we run this, it should be kind of interesting to see how this plays out. So again, we use the word if, then we have our parentheses. So if that condition is true, then we want to move it back to the left. So let's see what happens here. Well, it moved left, and now it's kind of parked here. But if we think what's happening, we move it so it's no longer greater than the width, we bump it back 10. The next time the program goes through, it hits this, adds 10 to it. Oh, now it's bigger than the width again. Let's take away 10. So that's why it gets stopped. So what we need to do is we need to, instead of hard coding in 10 and using plus and using minus, we're going to use the magic of -1. So what we can do is say int speed x. And if you're paying attention here, you will realize we're probably going to need an int speed y. Now, one thing that I used here is what's referred to as camel casing. I have a word and then something else attached to it. I put that second item where it would be capitalized so that it's easier to read that. So capital X and capital Y is part of it. That's a common thing that we do when we start putting multiple items together into a single name. We use camel casing. So we capitalize the first letter of every subsequent word, but not of the first word in the bunch. Now we can give speed x a starting value, and I will say 10. And might as well put y in here for now, because eventually we're going to want that. And these numbers we're just trying things. We can change the 10. It could be 5. It could be 8. It could be 7. It could be 12. Doesn't really matter what it is. Now, with that, we can say x is equal to x plus, instead of 10, we'll say speed x. Now, run often when you're coding to find out, okay, we're right back to where we were. But if our x is greater than the width, what we want to do is not just subtract 10 from it, just going to comment that out. Well, so if I put lines of code in that I may want to go back to or to remember, I will often comment them out, but leave them there, not delete them, leave them there. And it's not till I'm all done that I go through and start cleaning or organizing my code a little bit to get rid of those extra instructions that are still commented and not doing anything. But in the beginning, I prefer to leave them there. Remember, you should be adding comments to your code regularly. Like I added this comment here on it. Now, it may not be a movement to the right anymore. If we say speed x is equal to speed x multiplied by -1. Now, if we take a positive number and multiply it by -1, it becomes a negative number. But if we take a negative number and multiply it by -1, it becomes a positive number. And that's the magic of -1 that we're going to be working with here. And we'll see that happen. So let's see what transpires. Runs, and now, oh, and it went off screen. But now it went off screen on the left side. So that is solved by saying if x is less than or equal to 0, our left edge, open curly brace, return twice, close curly brace, speed x is equal to speed x times -1. Run again. Hits one side, bounces, hits the other side, bounces, and the object is bouncing. Sweet. Now you may notice it's going halfway off the screen here as it moves. So I'm going to modify speed x and make it 1 so it's even easier to see as it goes and hits the edge. Oh, it's going to take a little while. Probably should have shifted the starting position over, but we're not going to make it go all the way back to the left edge as well. But you'll see that it goes halfway off before then it bounces. And that's because the circle is drawing itself at the middle, which is what it's supposed to do, but we're not checking for the edge, we're checking for the middle of the circle, or that x value. So we're going to clean that up here and say, so if it's greater than or equal to the width, but we don't want the full width because notice it went too far, and it went exactly too far by half of the size of the object. So the circle is 100 pixels wide. So then that would be, let's shorten it by 50. Now we'll just start x at 600 so we don't have to wait quite as long for it to move over. And now we'll see it gets to the edge and bounces. So that's better. Now the same thing when we go over and check the left edge, we don't want 0. What we really care about is 50. So we could write in 50. Now you will notice I have the same number used twice. And this number is the half width of the object, and we'll also have a half height of the object. So realistically, we probably will want to even think about using a variable to store that. But we're not going to worry about that on this program. But down the road, we will do that as our programs get bigger and more complex. So we have it moving. It's bouncing. I'm going to put the speed back up to 10 so it can happen a little bit faster, and we can see the bounce occur as it goes from side to side. I said leave all the stuff until the very end, but in the interest of making it easier to see what is happening in the code on screen while you follow along with the video, I am going to delete a few things. And we're no longer just moving to the right, we are simply moving. So now that makes a little bit more sense. So I will put a comment in here and say, and what we have happening here is my checking my horizontal boundaries. If we want to repeat this process for my vertical boundaries, it's really going to be the same thing. So I will say if y is greater than or equal to, in this case instead of width, we have a magic sketch variable called height, and we know that, well, it's 50 is what we want. Now if we have a more complex object or a non-uniform size object, then that value would have to change to something else. Again, return twice, close out my curly. Now speed capital Y is equal to speed capital Y times -1. And repeating again, if y is less than or equal to, and what this case really is 0 minus 50, or just negative 50, but sometimes I think it helps to write it out. Put in my curly braces, speed y is equal to speed y multiplied by negative 1. So using the star sign as multiplication. So plus and minus, that makes sense. Star is multiply, and if we want to show division of a number, so if we were dividing by -1, we would use the slash, but we are multiplying once more. Now, while we have our x, we might as well add in our y, and then we add to that our speed y value. Now when we run this, we'll see we now have this ball which works fine everywhere except at the top. Oh, it's not 0 minus 50, it's 0 plus 50. Same way that it's 50 here, which is 0 plus 50, 0 plus 50. Again, this is why run often to see your code. And now we can see how this object is bouncing around, staying contained in the sketch boundaries. So we move it on the y, we move it on the x. So we have our updates. So we update the position, and then we check and see, hey, have we hit the boundaries? If so, we need to change that speed value so that we can keep the object moving on screen. If the object we're working with is more complex than a simple circle, things don't change a whole lot. So I've drawn a circle, and I'm going to change my fill color back to solid instead of transparent. So I drew a circle at x and y. Now if I were to set, so if we say that that is going to be, I don't know, the head of the object, and now I'm going to set a new fill color. I'll just use electric green right now, and I will draw a circle. And if I want to draw an eye, not a center one, I want it to be offset. So we're offsetting it. If we remember how in the previous program we would offset things by figuring out how many pixels they were off from one object to another object as they related to the whole grid. So if I want to draw a circle, and I will say it is at x minus, we'll say x minus 20, y minus 20, and I will make this circle 20 pixels in size. Now if we run this, we will see I now have an additional object. Now if I have two eyes, and this circle will, instead of being, so what we have to remember is x and y refers to the center of this circle. That's our kind of registration point. So we're drawing everything relative to that. So this time I will shift over 20 in the other direction. Now we did minus 20 on the y, so it went up into the upper part of that circle. Now we have two eyes. Now we need a mouth. So I'll choose a fill color. I'll just fill it with white. And for this, I'm going to draw a rect. And now this rectangle, I want to, I'll shift it down a little bit. And I'm going to shift it over, because rectangles draw not from their center, but from their top left corner. So I'm going to shift it over. In this case, I will shift it over 15. And then I will move it down. Just move it down 20. and I want to make it 30 pixels wide. I went over 15, so that would be half. So my width will be 30, and I want to just make it 10 pixels, not 100. That would be pretty big. Well, could make it 100, but that'd be really big. 10 pixels. Now, if I run this, we should see that I get rectangle. Oh, did I say minus y? I wanted plus y, not minus. I want it to be in the lower half. So now, this time when I run it, we'll see now I've moved it down. So that keeps the head on screen. But what if we have a body? Now for this body, we'll just fill it with blue. So when doing your basic kind of concepting, it's sometimes useful just to use really basic values. I'm using the red, green, and blue color values because it's easy to figure them out quickly on here. Notice that white 255 is white, but also 3 255s, so red, green, and blue turned all the way on, are also white. So I'll fill the body with blue, and I'm going to draw a rect. Now for this rect, I'm going to make it the same, so it's going to be just as wide as the body, so I don't have to mess with the horizontal part, but it is going to be a vertical shift, so we will have to go in and modify when we hit the bottom of the screen to keep this all the way on, as we will see in a little bit. So with this, it means I will start out at x minus 50, and my y is going to be plus 50, and I will then make this 100 pixels wide and 200 pixels tall. Now if we run this, you can see the body's going way off screen. So if we want that body to bounce and stay on screen, we need to adjust that position. And to adjust that position, so this added 200 to hitting the vertical boundaries. So if I put a comment in here and say this is our bottom, and put a comment in here, this is our top, left, right, it's useful sometimes to have those comments so you know which is which. So it's hitting the bottom, it's going too far. Well, we know we added 200 pixels to the height with this rectangle here, or not right here, because that was the height. So instead of checking at 50, we probably want to check at 250. So now when I run it, we can see that our character is staying completely on screen. So we've covered a lot of new ground here in this program. We've learned about using variables. We've learned about the two core functions of setup and draw. Setup happens one time. This runs once when your program starts. Draw will run 60 times per second, so it happens a lot. At times we have to be careful what we do because we can create infinite loops because draw keeps running, and those infinite loops can cause the program to run out of memory. So we have functions that don't return values because they have void as the return type. Setup and draw, these are part of the language specification. Now within that, we looked at how we can control things using variables. The variables were storing the location or registration point of the object as an x and y number, and then we're updating that. Then we're checking to see if we've run into the boundaries of our sketch using conditionals. We ask, if this is true, make this happen. And we've been able to enjoy the magic of minus 1.